Hello there and welcome to A2 Maths. We're on June 2018, paper 2, and here we're looking at question 7, a trig equation question. So solve for x in between 0 to pi by 2 the equation 4 sine x equals sec x. So let's just write out this equation. We won't write sec, we'll write 1 over cos at that point. So 4 sine x equals 1 over cos x. Okay, so we can't really do much of this now. Let's multiply everything up to the top, so we're just working on one row. So let's now multiply by cos x, and we get 4 sine x cos x. Now, from memorising my my double angle formulae, I know that sine of 2x is equal to 2 sine x cos x. So if I double both sides, I've got a 2 and a 4 there now, so I can now simplify this into this. So I'm going to get 2 sine 2x equals 1. Divide both sides by 2, I now have sine 2x equals 1/2. So now that I've got 2x inside my brackets here, I'll need to enlarge my domain to pi radians, because it was from pi by 2, and now that I've got 2x inside my brackets, it needs to be enlarged to pi. 0 is just enlarged to 0. Okay, let's now inverse sine. Inverse of sine is pi by 6 radians. The next one will appear at pi minus this, so 5 pi by 6. So therefore, if we then divide both sides by 2, we then get x equals pi by 12 and x equals 5 pi by 12. And both of those are in between 0 to pi by 2, so they are both correct solutions. Okay, so there we are. That's the answer to part A. Moving on to part B now. Solve for for theta in between 0 to 360, the equation 5 sine theta minus 5 cos theta equals 2, giving your answer to one decimal place. Now, it would be nice and easy if we had a 0 on the other side. We could just add the cos onto the other side and divide and make a tan. But in this case, we don't have this option available to us. So what we're going to have to use is the formula of r sine theta plus alpha. R sine theta minus alpha, actually, because there's a minus in between here. We're using sine because that's the one that's positioned first, and we're using a minus inside here because there's a minus there. We know that the sine angle addition formula looks like this. Sine theta cos alpha minus sine alpha cos theta. So that's what we're going to effectively use here. We're going to turn this thing here into r sine theta minus alpha, and then we'll set it equal to 2 onto the other side. So let's expand our brackets then. So therefore we have r sine, so we'll write it in a different order. You'll see why in a second. R cos alpha sine theta minus r sine alpha cos theta. I'm going to set this equal to the left-hand side. 5 sine theta minus 5 cos theta. So, if this left-hand side is identical to this right-hand side, then it must be the case that what's in front of sine theta must be equivalent. So equation 1, r cos alpha must equal 5. And equation number 2, same thing for the cos theta. What's in front of the cos theta on the left hand side is equal to what's in front of the cos theta on the right hand side, so therefore r sine alpha equals 5 as well. Now what we can do here with these two simultaneous equations is we can square both of them and add them together, so that will give us, we've probably done this lots of times before, r squared equals 50, because the sine squared plus cos squared will equal 1, and that would just cancel out. So we'll get r squared equals 5 squared plus 5 squared, that's 50, so therefore r is equal to 5 root 2. And we can also do equation 2 divided by equation 1 to give us our alpha value. That's going to be r sine alpha over r cos alpha equals 5 over 5. So therefore tan of theta will equal 1. So therefore theta is going to equal 45 degrees. Right, okay then, let's now separate our page. So we've now got an equation. We can simplify this left-hand side to 5 root 2 sine of theta minus 45 degrees equals 2. And again, we're going to have to change our domain. It's going to now have to be minus 45 to theta minus 45. So we're taking away 45 on both sides to 315. Okay, well, no, not equal to there, just a standard equality sign. Okay, so let's now divide by 5 root 2 onto the other side. So we're then going to have sine of theta minus 45 equals 2 divided by 5 root 2. So that's going to be root 2 over 5. And let's now do inverse sine of this value. So grab your calculator and make sure it's in degrees mode. And then do inverse sine root 2 over 5. And we get an answer which is 16.43. Then we need to find the second solution. Oh, hold on. Yes, this solution is in between this domain here, so that's fine. Then we need to find the second solution, which is 118 minus answer. So 118 minus answer, which is 163.57. That's still in between the range as well. There won't be any more in between this range. Now what we also have to do is add 45 to get our final answers. So 16.43 add 45 gives us 61.43. We'll write 61.4 because it's generally to 3 significant figures. 1 decimal place actually in this case. And then for the last one, 163.57 add 45 to 1 decimal place gives us 208.6 degrees. So there we are, that's the answer to both of these questions here. 9 marks for both of those. In question 7, let's now move on to question 8.